the cutest that I've ever seen. Give him 2 lips like roses and clovers, and tell him that his lonesome nights are over. Sandman, I'm so alone, don't have nobody to call my own. So please turn on your magic beam, Mr. Sandman, bring me a dream.
Oh, yeah, folks. That's what I'm talking about. That is Mr. Sandman. I love that song. Yes, I do. It is amazing. And it's by Young Original. You can't make that up. But no, seriously, folks, really. Young Original is a great band. I came across them quite by accident. A friend sent them to me because this is like one of my favorite songs by the Chordettes. It's in 1952, 1954, that area. But look, all I can say over and over, folks, is that I love that song, Mr. Sandman by Young Original. So why don't you go check them out at youngoriginalgroup.com. Like, share, and subscribe to their content. So what do we got today? Today I've got one hell. Well, I'm a little short there, huh? Come on. There we go. That's better. And, God, these freaking chairs are ridiculous. How's that? All right, let me just go check, make sure I can hear myself before we get caught up like yesterday. We're at 8 minutes of silence. I'm so pissed about that. Golly. All right. We are going to just check this real quick, make sure everything is good, folks. How you doing? How was your night, huh? Is this today, right here? Okay, I see it. Yep. Hold on a second, folks. We are live, and I'm just checking sound levels, make sure everything is good so we don't have any problems. Just hold on with me for 1 second. All right. So this, I don't see. Why is that? I do not see the video. Hold on a second, folks. We don't want to get started before this is all good. Trust me. All right. Hiya. All right, ladies and gentlemen, here we go. This is, I believe this one is what? What is this one today? Let me pull it up. Hold on a second. This is about the Elon Musk brain chip, but more than that, actually. We're going to go over the first patient who got the implant. We're going to also touch on actual computers made from brain cells, which is really cool. And if you are paralyzed or have a brain injury of some type, how might you go about contacting Neuralink like I did for this story? So good morning, I'm RJ Smith. It's 11 a.m., Sunday, March 22nd, 2026. And here we are. This is actually a makeup episode of the Crazy Podcast because I wasn't here last night, right? And today, we are diving into a story that sits right at the intersection of what I would call hope, science, money, and I guess even power, and the human cost of moving too fast. So let's get into it. Segment 1 is on Neuralink. They experimented on more than 15, maybe even 3,000 animals. 1,500 died. Verified the 1,500 died. Wasn't able to verify exactly how many animals they experimented on because they don't tell you that. But look, not long ago, the world was captivated just basically by the promise of paralyzed people possibly regaining their movement through this brain chip. Technology developed by Elon Musk's Neuralink. It sounded revolutionary. It sounded historic. And it sounded like the future had finally arrived, right? But behind that glossy promise, folks, there were already warning signals. Reports were raised, serious questions, after more than 1,000 animals and up to 1,500, but I think it's closer to 1,500, died in experiments tied to the company's testing program. Now, there have been allegations that some of the work was rushed, but before the headlines, there was already controversy. Take a look at this first video that I have for you, this one. So let me get over to the right screen. That is not what I need. Okay, here we go. So we're going to go over to the show side. Go ahead. All right, here we are. And we're going to be talking about this first video, which is off the freaking chain as far as I'm concerned. This is the animal testing that they're saying went so wrong, you know? Hold on a minute. Golly, look at this. That's crazy, huh? Okay, Elon Musk's Neuralink. We're going to go ahead and enlarge that so you guys can see it. Hopefully you can see it. Everything's fine. Looks good. Not too dark. Okay. Hold on, folks. 1 second. There we go. All right, now we're cooking. All right, so we're going to go ahead and start this rodeo off. We're going to pause that, go back to the beginning. Now, this is the animals that they used, they tested for this. Now, if you're like me, I do not like animal testing. I just think it's stupid. I know they do it with an end goal of helping humanity, but it's just a sick way to go about it, you know? 1,500 dead animals. Let's see what they're talking about.
We've been working hard to be ready for our first human, and obviously we want to be extremely careful and certain that it will work well before putting a device in a human. But we've submitted, I think, most of our paperwork to the FDA, and we think probably in about 6 months we should be able to have our first Neuralink in a human. So for the first two applications we're going to aim for in humans are restoring vision, and I think this is like notable in that even if someone has never had vision ever, like they were born blind, we believe we can still restore vision.
Wow.
Because the visual part of the visual part of the cortex is still there, yeah, even if they've never seen before, we're confident that they could see. And then the other application.
Hey guys, it's just me or Elon Musk has got to be an alien, man. He talks so crazily for being so smart.
Someone who has no ability, almost no ability to operate their muscles, you know, sort of like a sort of Stephen Hawking type situation, and enable them to operate their phone faster than someone who has working hands. I mean, as miraculous as it may sound, we're confident that it is possible to restore full body functionality to someone who has a severed spinal cord. So, yeah. And here you can see Sake, it's one of our other monkeys, typing on a keyboard. But now this is telepathic typing. So to be clear, this is he's not actually using a keyboard.
So this is coming directly from his brain.
The cursor with his mind to the highlighted key. It's also important to show that Sake actually likes doing the demo, and is not like strapped to the chair or anything. So yeah. So the monkeys actually enjoy doing the demos because they get the banana smoothie, and it's kind of a fun game.
Well, so that was with the animals, but it was supposed to be much more than that. It was so. All right, so let's just look at the. Without looking at that, Neuralink wants to test brain chips in humans. Shows monkey playing video games. I don't think that was the right video. Let's see if I can find it here. Yeah. All right. Well, let's just read it. So this is what they're saying about it. It's under federal investigation for potential animal welfare violations and internal staff complaints that we'll get to also later in the video, that its animal testing is being rushed. And they're saying that's caused needless suffering and deaths among the animals. And this is all according to Reuters and documents that they were able to review here. I was not able to get any of it, but I have this report. So they're developing a brain implant that it hoped will help paralyzed people walk again. And it is helping somewhat, as we'll get into, right? They have expectations like unbelievable. They want to make blind people see and disabled people, totally paralyzed people, to walk again. Now, that's a very big order to fill. And so far, we haven't seen anything close to that. It's been 2 years now, I think, since the first chip was implanted. They had a lot of problems, but a year later, they got it working again. So there is a probe into Neuralink's animal welfare practices, and the U.S. Department of Agriculture's Inspector General are the ones who are investigating that, and we'll see what happens. But they killed a lot of animals, folks. Hold on one second. Yeah, I'll do that. All right. So despite the controversy, on the right one there. Yeah. Look, despite the controversy, right? Neuralink rushed forward with human trials. The pitch was simple, was powerful, a brain chip. Now, this could help paralyzed patients communicate, type, control devices, and reclaim part of their independence. Now, they were told the implant could be trained to intercept brain activity and turn thought into digital action. And around the world, people were blown away. Just imagine, right? For families living with paralysis, this wasn't just innovation. This was hope. But of course, like all things in humanity, then came the question that always matters most. Did it actually work? Well, I have this video for you, and we're going to check that out, and I'll talk about it. Stay there, because there's a lot of stuff coming up later on in the show that you're going to be blown away by. Let's just play this here real quick.
A new brain chip developed by one of Elon Musk's companies is being described as a game changer. The chip is being trialled internationally and allows patients to control and manipulate laptops and other devices with the power of their mind.
It's a massive change in your life where you can suddenly no longer move any of your limbs, and this kind of technology kind of gives you a new piece of hope.
Though he's paralysed from the neck down, Sebastian Gomez Peña can now control his laptop and phone using just his mind.
Everyone in my position tries to move some bit of their body to see if there is any form of recovery. But now I think about moving my hand to the right, to the left, think about clicking my fingers, and the technology just understands what I want to do, and it does it. Yeah.
You wouldn't even know the chip was there until it needs a daily charge.
If you
See, and that's the thing, a daily charge, right? You have to plug it in, folks. Like an iPhone, you have to plug it in because it's somehow we're not able yet to attach our energy system with devices like this. And I don't see there should be no reason. Hold on one second. I'm getting a text from somebody. I want to make sure something's not right here. Hold on. I think I hear it fine. I'm not having an issue over here, are you? Okay. Yeah, I know. Well, let's check that out and see how that came across, and then we'll play it for them. Guys, I am not actually seeing a video here. I'm not seeing anything scheduled right now. That's crazy. That's really weird. Are you guys seeing this, I wonder? Because I'm not seeing it on YouTube. Damn, this pisses me the hell off. Yeah, man, I don't see what's happening here. I don't even see a video for us. Hold on a second. Damn it, man. Why does this happen? Okay. Wow, guys, am I online here? What the hell's going on? Crazy. Wow, might be closing this thing out, man. This is ridiculous. All right. It is not. It's playing. Here we go. Crazy. I know. Okay, so it is playing. Okay, good. So yeah, we're good, folks. Sorry about that. I just want to make sure. I don't want to get going and then, in the middle of it, someone send me an email. Oh, there's no sound. So here we go. We are good to go. I am going to check one more thing while we're here, just to make sure. Pull it up. And, okay, I am getting sound, so we're good to go. Everything looks great. Let me play the video again. And that should be fine, but we're just going to check. Hold on. Let's make sure. Okay, let me see here. I'm getting volume there.
Hold it to my head right there.
Okay, good, and we have volume there.
Yep. This means this is how we charge it.
So I'm charging the chip.
That is exactly what you're doing.
A keen rugby player and musician, Seb had just finished his first term at medical school when he made one ill-judged dive off a boat on holiday.
All right, folks, we're good. So let me go back to where I was. We were at Elon Musk's Neuralink here, and this is the story of one of the patients. Check this out, and I'll check back in with you. Here we go, guys. Sorry about the delay.
A new brain chip developed by one of Elon Musk's companies is being described as a game changer. The chip is being trialled internationally and allows patients to control and manipulate laptops and other devices with the power of their mind.
It's a massive change in your life where you can suddenly no longer move any of your limbs, and this kind of technology kind of gives you a new piece of hope.
Though he's paralysed from the neck down, Sebastian Gomez Pena can now control his laptop and phone using just his mind.
Everyone in my position tries to move some bit of their body to see if there is any form of recovery. But now I think I'll move my hand to the right, to the left, think about clicking my fingers, and the technology just understands what I want to do, and it does it. Yep.
You wouldn't even know the chip was there until it needs a daily charge.
If you hold it to my head right there, yep, this means this is how we charge it.
So I'm charging the chip.
That is exactly what you're doing.
A keen rugby player and musician, Seb had just finished his first term at medical school when he made one ill-judged dive off a boat on holiday.
When I dived, I hit the floor and hit my head, and alongside breaking my neck, also broke my front two teeth, and yeah, that's how I started.
But it ended up with Seb enrolling in the first UK trial of the Neuralink device, a 5-hour operation performed largely by robot, which, through a hole in his skull, inserted threads 1/10 the thickness of a human hair, connecting 1,000 electrodes to the part of his brain that controls hand movements.
It makes the experience a lot better.
This is the first time his doctors have seen him since the device was switched on.
That's really good control. This technology.
So a lot of this has to do with eye movement. You know, even you at home can use eye movement to control your devices. This is one step further. The eye movement still tracks, but also you have the brain now. You just think it, and it goes to the computer. Very, very cool.
It is going to be a game changer for patients with severe neurological disability. And those patients have very little really to improve their independence.
Neuralink, which allowed us to access the trial but didn't want to be interviewed, now confirmed 21 people have been fitted with the device, including 7 in the UK. Some users are able to train the AI that interprets their brain signals to type on a virtual keyboard, even control a robotic arm, or just played with their children.
Oh, you smoke, man.
The company's controversial founder promises even more.
As we advance the Neuralink devices, you should be able to actually have full body control and sensors from an Optimus robot. So you could basically inhabit an Optimus robot. The future is going to be weird.
Okay, so this is like the first cyborg, right? Your brain will be able to control one of the robots. So it'll be like your brain is in the robot. That's kind of weird. That's amazing. I would love to see that in action, you know?
But pretty cool.
Weird, and with it, serious questions about future users' safety and privacy, but a way off. Neuralink still needs to do larger trials and share its data with the public to prove these devices are safe and effective long term.
And look, despite the controversy, I would say that Neuralink pushed forward, right, with human trials. The pitch was powerful, a brain chip that could help paralyzed patients communicate, type, control devices, even reclaim parts of their independence. That's a big deal to somebody who's in a wheelchair paralyzed, because one of the things I hear constantly from these patients is, hey, you know, I have to call somebody just to move. Imagine that, being trapped in your body, your brain trapped in your body, but your brain can't control it anymore. And now here comes some alien named Elon Musk, and he creates this where you can actually start using your brain to move things. Incredible.
Elon Musk, whatever you think of him, does have a record of success. But in this endeavour, he depends on brave, determined volunteers like Seb to deliver it.
I actually am on the list for this because I had a brain surgery in 2020, I believe, right before COVID, where I had the right side of my face would twitch, guys. So, you know, I'd be in a restaurant and my eye would blink. My right eye would blink. And people actually thought I was winking at them. I remember one time this guy said, "What are you winking at me for?" And I was like, "Winking? Yeah, you're winking." I'm like, "No, man, I have a facial issue, my brain issue." And this is from an accident. So I went to the Florida State University, a doctor named Friedman. He's supposed to be the top guy, one of the guys who has the best record with this, which I found out was all bullshit. I went up there and I had brain surgery. What they were going to do was cover up my facial nerve with a sheath. See, the facial nerve is right by the brainstem and the carotid artery that comes up. Well, it lays right against your facial nerve. And sometimes, every time your heart beats, it will make the facial nerve twitch. So every heartbeat, I had a blink. It was crazy. I was told that little incision would be made in the back of my head, and I'd be good to go, right? No problem. Well, when I came out of surgery, I had no hearing. My vision sucked. And on top of that, I could barely move. But the biggest thing for me has been the complete loss of memory, short-term memory. So like I can be talking to you right now. If I don't have these notes in front of me, I could totally forget what I'm talking about. Anyway, I'm in Florida, so you can't sue the doctor. It's freaking crazy. They can freaking kill you, but you can't sue them. It's insane. Anyway, all right, so that's what's going on. Patients were told the implant could be trained to interpret brain activity and turn thoughts into digital action. Now, around the world, people were blown away. For families living with paralysis, this wasn't just innovation. This was hope. You know? But then, like everything, the question came that matters the most. Did Neuralink actually work? Well, let's take a look at those UK trials that they had, okay? And see, did it work? This guy, what is it? One of the first British patients. Right, this is one of the first British patients. And this is quite interesting now. This was, I think, the first implant, human implant. Check it out.
A handful of people in the world have been implanted with a brain chip made by Elon Musk's company Neuralink, and I'm about to meet one of the first people in the UK to get one.
It's a massive, massive change in your life where you can suddenly no longer move any of your limbs, and this kind of technology kind of gives you a new piece of hope.
Though he's paralysed from the neck down, Sebastian Gomez Pena can now control his laptop and phone using just his mind. You have this power of telepathy, effectively, and I'm just fascinated to find out how that feels.
Everyone in my position tries to move some bit of their body to see if there is any...
Right, I just wanted to give that to you again so you can meet this guy, because he was the first guy. He was the first brave guy to really face this on and on, right? But of course, there was a setback, like anything in the world, and things came undone in the brain, and it was a big problem. So let's go ahead and play that for you. And full credit to NBC, I believe, on this. Is it NBC? I think so. If not, I'll take the credit back.
Neuralink tonight is saying part of its brain computer chip malfunctioned in this week after it was first implanted into a patient's brain. 29-year-old Noland Argaba became the first person to let Elon Musk's company put a computer chip in his brain back in January. Neuralink, in a blog post, says some of the threads from the device retracted from his brain in the weeks after the procedure. The company did not immediately respond to requests for comment. The technology being developed to help patients with paralysis control things like computer cursors using only their minds. Dr. Natalie Azar is joining us now. Doctor, can you explain the role of these threads in this device and what happened when they apparently retracted in the brain?
Yeah, so basically what happens, Tom, is that a chip is implanted into the brain, and the chip has over 1,000 electrodes that are attached to about 64 of what are called threads. And these threads are essentially programmed to gather what your brain is thinking, basically what kind of movement you intend to do. And that then is sent to a computer. That information is gathered and then it's decoded, and those thoughts are turned into action. So what ostensibly happened is that some of these threads kind of lost their positioning or retracted out of the brain area where they were supposed to be, causing a significant reduction in the speed of this sort of.
Now, you got to wonder, folks, how the hell the leads all disconnected? It's almost like the body is fighting it, right? How does that happen?
Like transformation from these neural intent and these neural thoughts to actual, actionable movement. But they said they corrected it. They said that they sort of tweaked the algorithm and they have it up and running, and this guy is able to do even more than he was able to do before this happened.
The technology is so new here. Is it really any surprise that there's been a complication? Fortunately, he wasn't harmed, right?
Right. And so, I think people need to understand that the FDA has approved this device for clinical trials. There is no regulatory approval for more widespread commercial use or anything like that. I think it's also important to note that there have been some allegations about some quality control issues with the animal studies that were done prior to to this individual being the first human, that had this implanted. And look, complications absolutely can happen, Tom. There can be injection site infections. There can be, rejection even. So these clinical trials need to happen in humans to see that they are safe and effective before broader use and before full FDA approval.
So I guess what we should ask ourselves is, how did the very first patient, Nolan Arbaugh, how's he doing? How did it work out for him? And I have a video here for you I want to show you. A year after he got his brain chip, let's see what he has to say about it. Because really, he's the first Neuralink patient. And he's become the human face of this experiment, honestly. After being paralyzed in a car accident in 2016, he received the implant and began living inside what many people called the future of medicine. How is that possible? My question is, what is that future actually like when you are the first one? Well, Arbaugh spoke with reporter Elizabeth Vargas here about life in the year since receiving the chip. And here's that interview.
Couldn't be alone without help for more than half an hour at a time. You obviously couldn't send an email or watch a movie or play online chess. I know you're a big fan of online chess. You couldn't do anything without help. And once you got the implant, you said it was like magic. So talk us through this technology. How do you use it on a daily basis?
Yeah, it's I like to say it's pretty simple. What I mean by that is, of course, the technology itself is not very simple, but how it's used is pretty intuitive, and I use it for all sorts of things.
Do you have to turn it on? Like, do you turn it on?
I do.
Okay.
So I have a little hat that has a charger in it. It plugs in, and I can command the implant to connect or disconnect at any point. And after that, I just do whatever I want on a computer. Whatever anyone else can do on a computer, I can do, and I use it for all sorts of things.
Do you have to say something in particular when you say you command, the computer to do something? Do you say cursor move or?
Yeah, just in order to connect, I'll say implant connect, and it'll connect.
And then after that, you just think a thought, and it happens on the computer in front of you.
Yes, ma'am. That's basically how it works.
Have you had any negative consequences or side effects from this?
No, not really. At the beginning, there was some thread retraction, but so right now they've told me plus or minus 10% of the threads are in the, I guess their intended spot in my brain, but they changed how.
10% of the electrodes are actually working. What would happen if 100% were working? If you can do this with 10%, incredible.
All the signals are red, and I got cursor control back just fine. It's better than it was before, actually, and I haven't had any sort of physical side effects, mental side effects. It's been all positive so far.
So say you want to write me an email. You would talk me through what you would think.
So essentially, I just have cursor control. So I'll go into my email, click around, do whatever I need to do to send you an email.
So you go to inbox, start it. You click start. You say click start a new email.
Yeah, I don't have to say anything. It's just I think I want to click, and it clicks.
So all you have to do is think about it, folks.
Wow.
Left click, right click, whatever I want. And then after that, I will either use dictation, or I can use a virtual keyboard on my computer screen to type out whatever I want to say. And then again, just think, click, and it sends.
So I was struck by something you said recently, that you have read more in the last 14 months than you had in the many, many years after you were paralyzed and before that.
Right, so that makes sense, right? If you're paralyzed, you can't pick up a book, Kindle, hardcover, whatever it is you read on. You can't do that unless somebody sits next to you, turns the pages, and reads to you. So yeah, I can see that. But now with the eye tracking and the brain interpretation, he doesn't need any of that. He doesn't have to flip anything. He just tells it to read it, and it basically scrolls for him. Incredible. Incredible.
Implant was put into your brain. This implant allows you to read a book on your own. Or in your case, many books.
Yeah, it's something that I missed a lot. I was an avid reader before my accident.
Yes! As a Hollywood producer and a best-selling novelist, I love hearing that when people still love to read, because honestly, our society today is video-centric. Very few people read anymore like they did back in the heyday. So this is good to hear.
And reading books just kind of wasn't very possible after my accident. I got stuck listening to audiobooks, and those are hit or miss. Sometimes you don't like a narrator. Sometimes the book just doesn't sound the same. It's better to read. So I've been able to use like a Kindle or other reading apps, and I read all the time now. It's one of my favorite pastimes.
And you now have a job. Is this because of Neuralink?
Yeah. So I'm traveling around and speaking. So I know there's plenty of other things I could do, but it's something that I have a big passion about. Talking about Neuralink, talking about my faith, my story. So I travel around and speak to whoever wants to hear me at this point.
That is absolutely incredible, right? I mean, can you imagine what it takes for him to travel around? Brave individual. And it seems like it's working okay for him, the part that still works. It's incredible. But like everything else, technology sometimes has a bad side. So another layer of controversy. Here it is. A former employee filed a $10 million lawsuit against Elon. She alleged that she was exposed to monkeys carrying the herpes B virus. What? When I heard that, I was like, how is that possible? And then after she reported her injuries, she was threatened and then fired. Less than 24 hours after disclosing her pregnancy and the issues. Now, those are allegations in a lawsuit, but if true, they paint a disturbing picture overall of the environment inside the company. It's not just questions about the product, questions about the culture, questions about safety, questions about what was happening behind the scenes. So here is the report from that employee who claims she got herpes. She's fucking Christ. I can't make this up, folks. You just can't make this shit up, man. It's just insane. Here we go.
So Neuralink, Elon Musk's brain implant company, is being sued by a former employee who says that she was fired after she complained that she was forced to work in unsanitary conditions, including with monkeys that were infected with the herpes B virus, which can be very deadly if it infects humans. Lindsay Short filed a lawsuit last week in California state court, accusing the company of retaliating against her after she complained that she was forced to work with these animals that were infected with the disease. She alleges that on one incident, a monkey reached through the cage bars and scratched her hand, causing a breakage in the skin and possibly exposing her to herpes B virus. On another occasion, she alleges that a monkey scratched her across the face. Short worked as an animal care specialist for Neuralink. She claims in her lawsuit that when she demanded that her bosses provide her with protective gear, that they then retaliated against her. So Neuralink, Elon...
I don't know. It sounds kind of sketchy. I mean, can it happen? Yeah, but a company like Neuralink, backed by the alien of the decade, crazy. But you know what? When you get away from, while Neuralink really fights its own battles, right? The wider world of brain tech is moving fast. Scientists in places like Switzerland are now growing tiny clusters of human brain cells. And this is done in petri dishes to build what some are calling a living biological computer. Think about that. These lab-grown mini brains. They call them organoids, and they fire real neural signals while using only a fraction of the energy required by traditional silicon processors. Look, so now the question shifts. We are no longer just asking what machines can do. We are asking what happens when biology itself becomes the machine. Take a look at this first post video I have for you. I like first post. I like foreign press because a lot of it is really good and true, unlike, some media places in America. All right, here we go, folks.
Next story, we go inside the human brain. Forget AI chips and supercomputers. The newest tech whizzes aren't silicon. They're squishy, tiny, and they live in a petri dish. Welcome to the world of biocomputing, or as the scientists call it, wetware. In a Swiss lab, scientists are feeding tiny clumps of human brain cells the nutrient-rich cocktail they need to survive. Because these mini brains aren't just cute, they are working as real-life computers. The idea is simple. Instead of trying to mimic the brain with circuits, why not use the actual thing?
Wow.
And the perks are juicy. Biological neurons are 1,000,000 times more energy efficient than artificial ones. Plus, they can be endlessly reproduced, unlike high-demand AI chips, which tech giants fight over like holiday Black Friday deals. So how do you make a brain that doubles as a processor? Well, these cells are originally taken from anonymous human skin donors. They have the superpower to transform into any type of cell in the body. So, start with stem cells, nudge them into neurons, and bundle them into tiny organoids. Stick on some electrodes, give them a tiny jolt, and voila, live neural networks firing away like a microscopic brain party. 10 universities worldwide are experimenting with Final Spark's brain organoids, so much so that the company even streams a live feed of the neurons at work. At the University of Bristol, researchers used one organoid as the brain of a simple robot that could distinguish Braille letters. Across the Atlantic, at Johns Hopkins, scientists are harnessing similar organoids to study conditions like autism and Alzheimer's.
This is, hold on a second. This is absolutely incredible, right? Because we're not talking about a computer chip here. We're talking about actual human brains, organoids. How does that work? I mean, it's outside of the body. I guess they grow them, like they said, with stem cells. Incredible.
Of course, there's a catch though. These little geniuses can die mid-experiment. Scientists have had to start over more than once. Each organoid can live up to 6 months, offering a limited but tantalizing window into brain function. And before you panic about a Matrix-style uprising, these organoids aren't about to become conscious. With about 10,000 neurons compared to our 100 billion, they are just restricted to labs. Still, they have a mind of their own in mysterious ways. Scientists say that when they open the fridge in which they are kept, they can see spikes in their neural activity. Lines suddenly start spiking on the screen next to the incubator, indicating significant neural activity. Scientists have spent years trying to figure out why.
Yeah, I mean, think about that. How the hell do these brain cells just start, like, basically thinking on their own without any other connections in the brain that are required? Apparently, outside the brain, the research now, ladies and gentlemen, is for external brains, where maybe you can have a Wi-Fi connection from your fucked up brain to a brain that is plugged into the wall there and have everything back that you lost. That's incredible. Absolutely insane. I don't think this has ever been even thought possible in our lifetime.
Ghosts? Quantum magic? No, just another brain mystery. For now, wetware is more science fantasy than reality. But over the next 20 years, these mini brains could help AI go green, unlock brain secrets, and maybe even teach us how our brains really work.
I would love to know how my brain works or doesn't work, to be honest with you. So I mentioned earlier that I had applied for Neuralink, and I'm actually on a list. So, that would be great because this surgeon took away my hearing, right? In this eye, in this head, and my eye is worse on this side. Can't really see that much. And the balance, I've lost all balance and I've lost memory. So I hope I am one of the people selected because I would love to get that back. As a movie producer, vision and sound are everything, right? You've got to edit your videos. You've got to work with other producers in editing sound and SFX. And I just don't have that ability because I hear in mono now. Anyway, this is the next one, This is the next big thing I'm going to be tackling. But let's talk a little bit more about the biological computer. What you're looking at on the screen is just that. And I would call this the next major leap. And we have an Australian startup, really, Cortical Labs, who has unveiled what they call CL1. And it's described as the world's first commercial biological computer. The system combines human neurons with silicone hardware. And the company says it can learn. It can adapt in ways that could challenge traditional AI computing. That is not a small claim, folks. If it holds up, this could reshape how scientists study disease and how computing systems actually evolve. And I think it'll affect how we think about the future of intelligence itself. So here's the report on CL1, the science behind it, and why biological computing may be opening the door to an entirely new era.
Would be embedded in.
CEO and founder Han-Wang Chong says it fuses cell-derived neurons with silicon, creating a new class of AI known as synthetic biological intelligence.
Unlike using artificial neural networks, we grow real biological neurons into networks onto computer chips.
It sounds like science fiction, but Han says the CL1 is capable of learning and adapting faster than standard silicon-based AI, while consuming significantly less energy.
We take blood or skin and we can transform them into stem cells, and from stem cells into brain cells or neurons that we then use them for compute and intelligence.
Han says the neurons grow on silicon chip with tiny electrical contacts connecting them to the digital hardware. And it's equipped with an artificial life support system to keep the cells healthy.
We have pumps like the heart, waste feeding reservoirs, filtration units like the kidneys, and we have a gas mixer to take carbon dioxide, oxygen, and nitrogen.
Han says the CL1 could revolutionize drug testing and personalized medicine.
With this kind of technology, we potentially could grow neurons taken from patients with, say, a dementia or with epilepsy, and test compounds and drugs that would then be personalized and tailored to that patient.
But Han believes the CL1's potential doesn't end there, saying it could usher in a new age of AI.
In the short term is we can use it for life sciences, for personalized medicine, for drug discovery and development. But the longer term vision of the company here is to pioneer a new form of computing where we can actually use these neurons that can process information with much quicker speed, with much less data, and with much more energy efficiency so that we can get to intelligence but without the significant cost associated with it.
CL1 computers are destined for laboratories and research facilities capable of cultivating their own cells. They'll be manufactured to order and ready to ship later this year.
Okay, I can see the first living cyborg with all this technology, without a doubt, is coming soon to a theater near you. I don't know. Look, guys, I want to thank you very much for coming by. Neuralink really has sold the world a vision, right? And it might be an awkward vision of the future. A man with paralysis controlling a computer with his mind. And for a moment, it looked incredible. it looked hopeful. And it certainly looked historic. It looked like science fiction had finally kicked the door open. But then reality hit. Because for people living with paralysis, this is not a spectacle. It's not fandom. And this is not a billionaire mythology. I say this is hope. Without a doubt. Real hope. Human hope. And hope deserves truth, not spin, not worship. Not a glossy sales pitch, just the truth. Because when you are talking about the human brain and human body and the fragile hope of people desperate for a breakthrough, the truth is not optional. It's everything. Some stories are hard to watch, folks. They stay with you. They sit in your chest a little longer than you expected. And if you felt something, maybe even a little bit watching this, that means your heart still works. Boom, 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 right? And in the world that is constantly pulling us apart, that is a beautiful thing. So hold on to that, folks. Hold on to your compassion. Hold on to your kindness. Hold on to each other. Because it can only get better. I'm RJ Smith. Thanks for coming by. Be gentle out there. And I'll see y'all right back here tonight at 7 p.m. for today's episode. And with that, I'm going to send all you people out of here. Just to leave. Go away. Yeah. Have a good one, folks. I am RJ Smith. This has been the Crazy Podcast. Hey. Yeah.